Hello everyone. In this video, I'm going to discuss about statically induced EMF and dynamically induced EMF in a conductor. And what is statically induced EMF? Already we discussed the EMF induced in a conductor with respect to stationary conductor and change in magnetic flux is called as statically induced EMF. The EMF induced in a conductor with respect to stationary conductor or coil, stationary conductor or coil and change in magnetic flux. Change in magnetic flux is called as statically induced EMF. And again, the statically induced EMF can also be classified into two types. One is self-induced EMF, another one is mutually induced EMF. And what is self-induced EMF and mutual induced EMF? First one, self-induced EMF. Self-induced EMF. And to explain this concept, self-induced EMF, I am considering one iron core. I am considering one iron core, and in this iron core, I am considering I'm wound one winding or coil around this iron core. And this is the coil or winding. I'm This winding is wound around this iron core, and when this coil is connected to the supply, it is connected to some rheostat. When it is connected to the coil supply, this coil is connected to the supply, and this is iron core. And whenever this winding is connected to the supply, then current starts flowing in this coil, and current I is flowing in this coil, flowing in this coil. Okay, whenever current flowing in this coil, this iron core will get act as a magnet. This iron core will get act as a magnet. And suppose this is north and south pole when it is acting as a magnet. When this is the rheostat variable resistor. When I am wearing this resistor, this is the variable resistor. When I am wearing this variable resistor, this current is also changing. This current is also changing. When current is changing, and the current in the coil produces magnetic flux. The current in the coil produces magnetic flux, and the flux is flowing like this. It is flowing from north pole to south pole. The flux produced by the current in the coil is flowing from like this, north pole to south pole. This is the flux, and it is flowing from north pole to south pole like this. And it's flowing like this. And whenever this current is changing, the flux produced by this current is also changing. The flux produced by this current is also changing. Here, I'm writing the point wise. First, because of this variable resistor, because of this current, there is a flux in this iron core. Okay, when this current is changing, when current is changing, current, current I is changing. changing. Therefore, the flux produced by this current is also changing, and the flux phi is also changing. Flux phi is also changing. This flux is changing with respect to constant coil. Therefore, here coil is constant. Coil is here the coil is constant. Here first current is changing because of by wearing this variable resistor. This flux produced by this coil is also changing, and then this flux is changing with respect to constant coil. Therefore, EMF is inducing in this coil. EMF is inducing in this coil. This EMF we are calling as statically induced EMF. Sorry, self-induced EMF. This EMF we are calling self-induced EMF. Okay, and the current in the coil is changing by wearing this variable resistor. When current is changing, the flux produced by this coil is also changing. Flux produced by this coil is also changing, but the coil is constant here. Therefore, the relative motion between conductor, coil, and magnetic flux. Therefore, EMF is inducing in this coil. EMF is inducing in this coil. That EMF we are calling as self-induced EMF. That EMF we are calling as self-induced EMF. Is this clear? Therefore, EMF is inducing in the coil. That EMF we are denoting. Therefore, the EMF E is equal to minus N into d phi by dt. EMF is equal to minus N into d phi by dt. Why this negative sign? This negative sign because of Lenz's law. Negative sign because of Lenz's law. Okay. Now, what do you mean by Lenz's law? Effect opposes the cause of its production. What is the effect? Here induced EMF is the effect, and already we are applying some voltage. This is the cause of this production. Okay, now, this effect will opposes the cause of its production. What is the cause? This original voltage. That's why negative sign. Effect will oppose the cause of its production. Lenz's law. Effect will oppose the cause of its production. This is the statement of Lenz's law. Effect will oppose the cause of its production. This is the effect. Induced EMF is the effect, and this original EMF is the cause. This induced. That's why we are taking negative sign here. Negative sign here. Negative sign. Is this clear? Yeah. Then the definition of self-induced EMF. Definition of self-induced EMF is nothing but when an EMF induced in a coil, when an EMF induced in the coil due to the change of its own flux, its own magnetic flux linked with it is called Self-induced EMF. Self-induced EMF is called self-induced EMF. When an EMF induced in a coil due to change in its own magnetic flux. Remember, this is very, very important. When an EMF induced in the coil due to the change in its own magnetic flux. Due to the change in its own magnetic flux linked with it. Own magnetic flux linked with it is called self-induced EMF. Then the EMF induced in a coil is called self-induced EMF. See here, and I'm considering the coil. Okay, now, and in this coil, there is a magnetic flux phi. This magnetic flux is linking with this coil only. This change in magnetic flux is linking with this coil only. Therefore, because of change in magnetic flux with respect to this stationary coil, therefore EMF is inducing in this coil is called self-induced EMF. Is called self-induced EMF. Remember, is this clear? This is about self-induced EMF. Next, we are going to discuss mutual induced EMF. What do you mean by mutual induced EMF? Second one, mutual induced EMF. Mutually induced EMF. Okay. To explain mutually induced EMF, I am considering two coils. I am considering two coils. To explain the concept of mutual induced EMF, I am considering two coils. Same, I am considering two iron cores, and then I am considering two coils. Two coils, and remember, and in here in these two coils, the first coil, this is coil 1, this is coil 1, and this is coil 2. First coil is connected to the supply with variable resistor. Is connected to the supply with variable resistor. What will happen when it is connected to this supply? Then current is flowing in this coil. Then current is flowing in this coil. Then I of current is flowing in this coil. I of current is flowing in this coil. When the current is flowing like this, the current I is flowing like this. When current is flowing, then it produces magnetic flux. Current is flowing, it produces magnetic flux. When current in the coil produces magnetic flux. Current in the coil produces magnetic flux. The flux is flowing from north pole to south pole. Suppose this is north pole, this is south pole. Okay, and observe clearly, and only first coil is connected to the supply. Because of this supply, there is a current is flowing in the coil. Because of current, when wearing this variable resistor, current is also changing. This magnetic flux is also changing. Because of this magnetic flux, EMF, the magnetic flux, change in magnetic flux is linking with this first coil. Therefore EMF induced in the first coil is called, we are calling self-induced EMF. And observe clearly, I am considering second coil nearer to the first coil. Second coil nearer to the first coil. Therefore, the change in flux in the first coil is also linked to the second coil. Observe. Change in the flux in first coil is also linked to the second coil. Therefore, in second coil also EMF is inducing. In second coil also EMF is inducing. We are not connecting any supply to the second coil because the change in flux in the first coil induces EMF in the second coil. Once again, the change in flux in the first coil induces EMF in the second coil. Induces EMF in the second coil. This is called mutual induced EMF. This is called mutual induced EMF. Is this clear? There is a EMF in second coil. Okay. And here the definition of mutual induced EMF. When an EMF when an EMF is induced in a coil due to changing changing magnetic flux, changing magnetic flux of neighboring coil, neighboring coil is known as mutually induced EMF. Is known as mutually induced EMF. Is known as mutually induced EMF. When an EMF induced in a coil due to changing magnetic flux in neighboring coil means the EMF induced in the second coil due to changing the flux in first coil. Therefore, that EMF is called mutually induced EMF. Is this clear? This is about statically induced EMF and dynamically induced EMF. Okay, this is only this is only statically induced EMF. Statically induced EMF of two types: self-induced EMF and mutually induced EMF. Is this clear? Yeah. Thank you.